In this final activity in our series of dealing with inequalities, we're going to look at something called compound inequalities. And this is where we have two inequalities that are operating at the same time. And there's some different phrases or different parts. There's ors and there's ands. And they handle them differently. There's ors and ands. And then there's ones where you don't see the or, the and, but we have to understand what this term means. So we're going to look at all three of those, the or, the and the one without either term in it. So let's start with the or. In an or statement, it's this or that. So either one of these can be true. So we're going to look at them kind of separately and see where they cross over. So x is less than or equal to 0. So that would be from here to the left. X is less than or equal to 0. So I'm going to actually go ahead and show that right here like this. So it's this is true, or x could be greater than 2, which means this also here could be true. So basically what you have in this situation is the only things that aren't true are numbers that are less than 2 and greater than 0. So there's a space here in between. So we actually have both inequalities acting at the same time. So we could say this is true or this is true. So I could pick a number like the number 6 and it would be true because it fits this one. But if I pick the number 1, the number 1 does not work for either of these. 1 is not less than 0 and it's not greater than 2. So and that's why those numbers are not indicated on the number line. There's some other kinds of ors where you don't have two lines, which we'll see in just a moment, but that's a simple idea of or. Now the difference with and, I'm going to go back to the or for a second because this is either is true. And the and is both are true. So when you say and, it's this and that both have to be true. So when I say x is greater than -1 and x is less than 3, so now we're going to have x greater than -1, so there's the -1, and x less than 3, there's the 3. So for both of those to be true, the only place that is true is in between those two. So you see, for x to be greater than -1 and less than 3, these are the only numbers that work for that. If I pick numbers beyond that, like x is 4, well, x is 4 works for x is greater than -1, but it doesn't work for x is less than 3. So the number 4 would not fit this compound inequality because it only works for one of the two. And in the case of both, it has to be true for both. Both have to work. So this is the representation of that. You can see that there's a very limited number of answers for this compound inequality, whereas for this one, there's lots and lots and lots. In fact, there's an infinite number of answers because you can go infinitely in either direction. There's actually only a few numbers that are not true for this one. So what about number 3? Well, if x is, you have to think about what this means. X is more than -4 and less than or equal to 4. So it's really x is between these two places when it's written like this. X is greater than -4, which is right here, and less than or equal to +4, which is right here. So I have a solid dot on one end and an open dot on the other. And so the values that make this true are actually in between those two places. If you picked a number beyond this, like -5 or +5, that would not be true in this inequality. So it looks like that when you graph it correctly. And let's look at another or. So x is greater than or equal to 5, or less than or equal to -6. So greater than or equal to 5 is out here. X is greater than or equal to 5, so that goes that direction, and x is less than or equal to -6. It goes that direction. And so now you can see that actually all these values in between would not be true. So it's this or that. Because if you picked +6, that works for this one, greater than 5, but it doesn't work for that one. And that's where the or tells you that either of these is true. They don't both have to be true at the same time. And so that's what that looks like with the arrows going away from each other. Again, you just have these values in between now that are not true for this compound inequality. Another example. Now this one's interesting because it says x is less than 10 and x is greater than -8. So think about where is x. It's between 10, less than 10, and it's greater than -8. So it's between -8 and +10. So when they're written like this, with the symbols this way, then it really is telling you that x is between these two places. And that's what it shows, x is between. So values of x that would make this true, like 0, is less than 10, but greater than -8. Another and both have to be true. So if we say x is less than 9 and x is greater than or equal to 3, so less than 9, but greater than or equal to 3. So really we're between 3 and 9. So these are the only values between 3 and 9 that would make this true. So combining inequalities now, we have multiple dots. Again, we have an and situation. So x is less than or equal to -2 and greater than or equal to -5. So we're really less than -2, greater than -5, less than or equal to, so we have the solid dots. So I'm talking in between -5 and -2. And they both have to be true. So both are true. And that's the only place that's true. So ands often have fewer answers that are true because both have to be true. It's more difficult to make both true than it is to have an or where you have one or the other, which we have here, or. So we have this or that. So x greater than or equal to 12, greater than or equal to 12. So we have x greater than or equal to 12, or x less than -16. So really the only thing that's not true are these numbers in between. A couple more examples here. There you go. So another and. So now we have x greater than 10, x less than 20. So greater than 10, less than 20. So we're in between the two. Greater than 10, less than 20. Greater than 10. So that's all that's true for this one. And then finally, we have this x between these two places. So greater than -3 or equal to -3, less than 1, open circle on the one, closed on the other. And that's that one there, that one there. So we're in between the two, at 1 and -3. And that's how you graph compound inequalities.